All right, here's a continuation of independent and dependent events. This first slide here that we're looking at is a review of what is independent and dependent. So think about replacement is independent. Dependent is when you don't replace a card from a deck. So that probably the second event will be affected. Example 1. Determine whether the events are independent or dependent, and then calculate the probability. A bag has 10 red, 12 white, and 8 blue marbles. 2 marbles are randomly selected from a bag. What is the probability of drawing a blue marble, then replacing it, and then grabbing a red marble? So let's count the total number of marbles. So we would add up 10 plus 12 plus 8, giving us 30 total marbles. This is considered replacement, so it is considered independent. So the probability of blue and then red. So the probability of blue is 8 out of 30. And then the probability of red is 10 out of 30. And then you would multiply those events together, multiply across. So 80 over 900. And you can reduce that fraction. So I'm going to divide it by 10. And then divide it in half. Part B. What is the probability of drawing a blue marble and then a red with no replacement? So now this is a dependent set of events. So when we draw a blue marble and then a red without replacement, the number of total marbles has now decreased when you draw that second marble. So the number of blue is 8 out of 30. Now you did not replace that blue marble, so now the second event has 29 total marbles. And then the number of red marbles is 10. We multiply across. And I'm just going to divide it by 10. Example 2. Determine whether the events are independent or dependent, and then calculate the probability. A box contains 10 balls. 6 of them are black, and 4 of them are white. So the total number is 10. We select 2 balls, one after the other. All possible outcomes are clearly shown in this tree diagram. So this is the starting point. So when you create a tree diagram, you have a 6 out of 8, or 6 out of 10, excuse me. So 6 out of 10 for that first selection, or 4 out of 10 to get black, or excuse me, get white. So here's the white, here's the black. Now you're going to go ahead and select one more time another marble, but you're not going to replace it. So notice when we select that second marble, there's one less black marble and one less total. If you select a white one, there's still 4 red ones. If you circle this here in red, out of 9. And then we go to the next tree branch, 6 out of 9, 3 out of 9. So what you do next to get the 2 events, so to get a black and a black, you'd multiply those branches together. So 30 out of 90. If you get a black and then a white, you multiply those branches together. If you get a white and then a black, multiply those events together. And then a white and a white, multiply those together. So let's go ahead and answer some questions. The probability that both of the balls are black. So we have a black and then a black. So you just look at that end set of branches. So again, 30 out of 90, or reduce to 1/3. Now you're going to get only one ball is black. So you could have black and then white. And then white and then black. So then what you do is you add those two events together, and you get 48 out of 90, and then reduce that fraction down to 8 over 15. All right, our last one. Both of them are the same color, so we're going to do the probability of a black and a black, or the probability of a white and a white. So here's a black and a black, and here is a white and a white. So 30/90ths or 12/90ths. Then you just add those two together. So 30/90ths plus 12/90ths is 42/90ths, or reduce down to 7/15. Example 3. Determine whether the events are independent or dependent. You randomly select two cards from a standard deck. What is the probability that the first card is a jack and the second card is also a jack? So this is telling you select two cards from a deck. So this is the first card is selected, and then the second one is now a decrease in the number of cards and then the number of jacks. So the probability of a jack and a jack. So the first jack is chosen, so there's 4 jacks in a deck out of a total of 52. The second event, now there is one less jack in the deck and one less card in the deck, and then you multiply across. And then you reduce that fraction down. Has a common factor of 12, so 1 over 221. Part B. You randomly select two cards from a deck. What is the probability that the first one is not a heart and the second one is a heart? So again, no replacement, so both of these are dependent. So the probability of not a heart so there are 13 hearts in a deck, so not a heart would be 39 cards left out of 52. Then a card has been chosen, so the second card is a heart. So now the second card is being chosen, and this one we want it to be a heart. So there are 51 cards left in the deck, and there are still 13 cards left that are hearts. So there's our 2 events. So now we're going to go ahead and just multiply those events together. We multiply across. And then reduce. All right, here's another example of a tree diagram. So I put in here some bullet points for you. Tree diagrams always are drawn horizontally. You draw one set of branches for each action in the experiment. You want to label the events at the end of each branches and label the probabilities of those branches. Then what you do is you multiply on each branch to get the outcome, and the probabilities on each branch must also total 1, because 1 represents 100%. So example 4, there is a 20% chance of rain tomorrow. So we start here, 20% chance of rain. So then there's an 80% chance of no rain. So that's the first event. Then it says, if it is raining, there's a 15% chance I will ride my bike after school. So if it is raining, I will have a 15% chance. So here's the rain, and I'm going to ride my bike, and I have a 15% chance. Then it says, if it is not raining, there's a 70% chance. So no rain, 70% chance that I will ride my bike. And what we need to do is fill out the rest of the tree diagram. So if this is 20%, then the other 80% is the other branch. If this is 15%, then the other branch will also total 1, 85%. And if this is 70%, then this would be 30%. And then what you do is you multiply. 2% or 20% and 15% gives you 3%. And then 20% and 85% gives you 17%. And you continue multiplying out those branches. So the question says, find the probability that I will ride my bike after school. So let's see where that falls. So I'm going to ride my bike after school. So here is riding her bike. Here is riding her bike. So what you do is you add those 2 probabilities together. And your answer will be 59%.